So we had some preview videos about the definition of standard deviation, and the big takeaway is that the standard deviation measures the spread of the data distribution. The more spread out the data distribution is, the greater the standard deviation will calculate to be. So here we have two sets of data in blue and green. In blue, we can see that it has a greater standard deviation than the green because the data is more spread out. The green, we can see the data is very clustered together around the mean. The mean is that dashed line there. Okay, we have to remember, since it is talking about like a distance, a spread, the standard deviation cannot be negative. If it's close to 0, that indicates the points are close to that mean. And then the further they are away from the mean, that means it's greater than your standard, it's a greater distance away. So it's increasing your standard deviation. So let's take a look at another set of data here. In example 1, it says, which of these data distributions do you think has the greater standard deviation? And in our purposes, right, we can see A here in green, and we've got this purple one. Select which one you think has the greater standard deviation. Hopefully you selected distribution A. We can see that it's got a larger distance away from the mean than distribution B, right? The means are here in the dashed sections. We also see that B's data is more clustered together versus A. But again, the larger distance away from the mean should have a larger standard deviation. So let's do some calculations next on how to work our standard deviation. And so in our preview videos, they went through the actual formula, how you could use the tables to find that, and we're going to show you a little bit easier way with your technology. So what I did is I asked the class what their shoe sizes were and collected the data below. So if you have a graphing calculator, any model of the 82 and above, you can use these calculator steps. So just like we did before with all of our regression data, we went to the list and we entered that in. So by pressing the stat button and enter, it's going to get you into your list options. In list 1, you're going to enter all the data individually. So you'd hit 5, enter, 6, enter, and so on, all the way up to size 13. Then you're going to tell the calculator to calculate that mean. And so you're going to go back and press your stat button. You're going to arrow to the right for your one variable stats, press option 1, and then you're going to have to hit enter 2 times. It might be 3 times for your 84 because you want to hit calculate, and it's going to show you the screen with all of your necessary values, right? So it's going to tell us the mean, standard deviation. We're also going to be able to find that 5-number summary. There is a more detailed video on how to use the graphing calculator if you want to see more screenshots of that in the Class Kick lesson attached to this. A quick snapshot, remember mean is your X hat, and so that's the very first thing that's going to show up in your one variable statistics. You're just always going to have to be mindful of what the variable is that you're measuring. So since we were talking about shoe size, we know that we can't have a shoe size of 8.8. We'd round up to 9 if we're talking about in those circumstances. Otherwise, just pay mind to what decimal place they want you to round to. Standard deviation looks like this S of X, and that will give you the distance away from your mean for your data set. And then if we want to continue down scrolling, you're going to get information about your 5-number summary. And this, remember, helps you with your box plots. N tells you how many pieces of data that you're working with. Here's your minimum, first quartile or your lower quartile, your median, your upper quartile or quartile 3, and your maximum. Again, technology is nice when you have to enter these items in anyways to find the standard deviation, but when you have a really large set of data, you don't want to worry about putting everything in order from smallest to largest. So you can get that 5-number summary pretty quickly here to assemble for your box plots as well. Just don't forget, with your box plots, you've got to check to see if you have any outliers. Now, for Desmos, you can do the same thing, just like we did for our regressions. We select the table, we're going to enter those values into X1, and then we're going to ask it to perform the statistical analysis for that data set. Whether I want to find the mean or the standard deviation, we can do all of those things. Again, you've got the video attached with more specific keystrokes on those. But like before, remember, you go to the plus sign and you can pick your table, enter all your items into list 1. Then here you go to your option 2, and you can either type in the items. If you wanted to find the mean, you can press MEAN and tell it where to pull the information from, and it will do that for you. If you wanted to do the standard deviation, you could type that in and tell it what list to pull the data from. You also can get those items by pressing the keyboard below, and unfortunately it's not going to pop up for us, but right here in the function section you can select that and scroll down to your statistics and pick what you want to find, the mean or your standard deviation. So if we're going back to what that would look like here, right, you'd have your table. I'm telling it to find the mean. Again, same thing as we saw with the graphing calculator, and your standard deviation, same thing as what we saw in the graphing calculator. So for our data set, we've got the mean being 8.83, so in reality that would be about size 9 shoe size, and the standard deviation is 1.85, so it's telling us our data is not too far from the mean of our data set. So let's look at the next part. Here we have 2 data sets for A and B. It says 10 people were given a questionnaire where the questions were optional, so it's possible that some people might answer none of the questions while others might answer all of the questions. So we've got 2 ways people could have answered. So you've got your data set for A, you have your data set for B. What we want to do is, 1, predict which distribution do you think has a greater standard deviation and explain why. And then we're going to go through and calculate the standard deviation for A and B using our technology, whether it's with our graphing calculator or whether it's with Desmos. So we're going to have you pause the video, do your prediction first, and then you can go and do your calculations. So if we're looking for the greater standard deviation, I want to kind of think about the distance away from the mean. And if I did the quick mean for each of these, it ended up being 2. So here's where the mean lies. And B has data that is further spread away from that mean. So I think that's going to be the larger standard deviation. When I do my calculations, my standard deviation for A was 1.15 for rounding to the hundredths. And for B, it was 1.49 rounding to the hundredths. So it's confirming that B is further spread out from the mean here of 2. Again, A, you've got the mean of 2 here. You've got the mode also appearing there. So it's less distance away from the mean for those remaining data sets. So continuing on with the idea of the questionnaire, suppose that all 10 people would answer all 4 questions. What would that dot plot look like? So could you sketch that and then figure out what would be the mean number of questions that are answered and what would be the standard deviation? Again, no calculations required for this. Pause the video, make your sketch, and then we're looking for the mean and the standard deviation. If all 10 people answered all 4 questions, then I should have 10 individual data points on number 4. So if I'm looking for the mean number of questions answered, that would have to be 4. And the standard deviation, well, if the mean is at 4, the distance away from the mean is not changing at all, it would have to be 0. So again, connecting the definition to a standard deviation, the distance away from the mean. All right, continuing on, still thinking about the survey. Draw a dot plot of the distribution for the possible data values for 10 people that have the largest possible standard deviation. Once you have that drawn, explain why that distribution, it has to have the largest standard deviation possible versus the smallest one possible in exercise 4. So again, pause the video, do your sketch, and write your quick explanation. So we know the smallest possible standard deviation is 0 because all the data points would be aligned with the mean, right? So we want to get the largest distance away from the mean of my data points. And so if I want to really get that distance as big as I can, I need to evenly distribute my 10 people to the furthest extremes for the number of questions answered possible. So I'm putting 5 people at 0 and 5 people at 4. So the mean for this ends up being 2, and the greatest distance away from 2 would have to be at this point here, right? So if I calculate the standard deviation, I can put my 5 zeros in my table, my 4s in the table, do my calculations. The largest possible standard deviation ended up being 2.1. So we want to get the distance as far as possible away from the mean, and by working those extremes, that will make that happen. All right, let's take a look at another data set. Here we actually have 3 pieces of data on the dot plot. So again, it's individual data values. We want to pick out which is going to have the smallest standard deviation of the 3 and which is going to have the largest, and be able to explain why. So let's have you pause the video and make your selections and explanations at this time. So again, we're trying to imagine the means for each of these data sets and the smallest distance away, so it's not going to have a large spread of the data. And so in that case, data set 1 would fit the bill. And then the largest one away from the mean, the largest spread of the data, that would have to be data 2. So here's kind of like our mean, and we see the larger spread of the data set. So smallest 1, largest 2. All right, let's go through our last example. It says, suppose that 4 students take a quiz. The minimum possible score on that quiz is 0, and the maximum possible score is 5. We want to figure out what is the smallest possible standard deviations for those scores and draw an example of what that could look like. And then the second one is, what would a set of 4 student scores look like to create the largest standard deviation possible? So let's pause the video here, make our 2 sketches, and we'll check back in. All right, so 4 people are taking the quiz. The smallest possible standard deviation is 0. So it would have to be everything aligning with the mean. So all 4 scores would have to be the same. It doesn't matter what the scores are, but I would have to have them all be aligned. So if I have 4 scores on 4, the standard deviation would be 0. I can do the same thing at 5, 2, 1, 0. It does not matter, but as long as all 4 scores are in the same spot, the mean would be in the same location, therefore the standard deviation is 0. Now, if I want to create the largest possible standard deviation, I want to get as far away from the mean as possible, I'm going to work those extremes. I'm going to give a couple a score of 0 and a couple a score of 5, right? Because then the mean would be 2.5. And that would create the largest standard deviation, which happens to be 2.88. All right, that ends our lesson on standard deviation. Again, by definition, it's talking about the spread of the data distribution. The more spread out the data distribution is, the greater its standard deviation. And remember, standard deviation is measured away from the mean. So the larger distance away from the mean, the greater deviation, closer, the smaller deviation. You can use your technology to calculate your standard deviation with your lists, whether it's your graphing calculator or Desmos. Now it's your time to practice for your day 5 data sets. We'll see you in class.